particular time. So that's what speed is all about. Something moving at a particular time, that is speed. Now, when we talk about, there's a difference between speed and velocity. Now, a car can move at a particular range, maybe 30 kilometers per hour. That is speed. Speed doesn't have to do with direction. It doesn't involve direction. Your mom travels, your mom drives your car maybe at a particular speed, but there is no direction. But when we start involving direction, then that is velocity. Okay? Now, you've heard of scalar and vector quantities, isn't it?
Yes, sir.
Okay. What's a scalar quantity, please?
I don't think I can remember.
Okay. A scalar quantity is actually a quantity that has magnitude, but no direction. So you might need to write that down. Please make sure you're writing down this stuff. A scalar quantity is actually a quantity that has...
Wait.
Okay. Ayo, please, wherever you are, I need you to put on your videos now. Ayo, use your videos right now. Ayo, please use your videos right now, or I put you in the waiting room. Okay. Sorry, Ayo, can you hear me? I need you to put, do you have your writing materials?
Yes, sir.
Okay. So I will also need your participation in this class. Do you understand?
Yes, sir.
Sorry, were you in Deeper Life High School?
Yes.
Really? And I don't know you? It's okay. But you know me, right?
Yes.
Okay. Now, let's continue. Now, like I said, a scalar quantity is a quantity that has magnitude, but no direction. It has magnitude, but no direction. While a vector quantity, has both magnitude and direction. Now, from what we have said about speed and velocity, what do you think? What quantity is speed? Is speed a scalar or a vector quantity? Is speed a scalar or vector quantity?
Speed is a scalar quantity because it does not need the direction of motion.
Awesome, awesome, cool. Awesome. What about velocity?
It's not a...
What about velocity?
It's not a velocity.
Okay, velocity is a vector quantity. All right, I'm going to be sharing my screen now. I'm going to be using that to teach you guys now. Okay, let's go over to my screen right now. Okay, can you see my screen? Is it clear now? Oh, sorry, this is projectiles, sorry. We're not dealing with projectiles now. Let me get the screen out. Okay, okay. Where is it? Where are you? Where are you? Where are you? Sorry, just okay. Sorry, just give me a few minutes. Okay, can you see my screen now?
Yes.
Okay. Okay. Awesome. Awesome. Okay. All right. Let's continue. Okay. From here now. Now we see speed is a measure of how far an object moves in a given time. Now a car is traveling at 60 miles every hour. This means the car travels 60 mph, that's miles every hour. A jet is traveling at 350 meters per second. Remember, speed is measured in meters per second. Speed is measured, that's the unit for speed, meters per second. All right. Okay. The speed of an object does not depend on direction on which it's traveling. That means direction is not involved in speed. When we talk about speed, there is no direction. We're only talking about how it moves at a particular time. But velocity has to do, velocity has to do with but when you talk about velocity of an object, you're talking about the rate of displacement. So that means time is being involved. Speed is involved. Direction is involved. Okay. When we talk about velocity, we're talking about, okay, is this car moving due north? Is this car moving in the north direction, or is it moving in the south direction? So direction is involved right now. Is involved right now. Okay, now a car is traveling north with a velocity 10 meters per second. You might be surprised, very, very surprised, that the unit for speed is the same thing with the unit for velocity. But what's the difference between both of them? What's the difference between speed and velocity? Who can tell me? What's the difference? One difference.
Because speed is a scalar quantity and velocity is a vector quantity.
Thank you very much. It's a vector quantity, but one of the things that differentiates them is direction. Direction. Directions. That's just the difference. They have the same unit. 10 meters per second can also be regarded for speed. 10 meters per second can also be regarded for velocity. But what differentiates them is the direction. Now, as the car goes around the corner, the speed of the car, of this car, remains the same. But what changes? The velocity. The velocity changes in the fact that this car is now traveling in the north direction. When the car moves again a bend, it's traveling from the north, maybe to the east direction. So the velocity is changing, but the speed remains constant. Do you understand that analogy?
Yes.
Yes, sir.
Okay. Now, this is the formula for speed. I guess you know that speed is distance traveled over time taken. You might need to write that somewhere. Distance traveled over time taken. You know, distance is measured in meters. Time is measured in seconds. Speed is measured in meters. So when you bring them together, you bring meters on top, seconds below, that becomes meters per second. That becomes meters per second. Okay, the standard unit for speed in physics is meters per second, but we could have other units such as kilometer per hour. Kilometer per hour, we could have other unit like that. So you might be given something in kilometer per hour and asked to convert to meters per second. You must know how to convert. How do you convert kilometer per hour to meters per second? All you just need to do is, how many kilometers do we have in 1 meter? That's 1,000. So you multiply whatever thing you were given by 1,000 divided by how many hours in seconds? That would be 60 times 60 divided, that's whatever. If you were given 10 kilometers per hour, convert to meters per second, that would be 10 times 1,000 divided by 60 times 60. Do you understand that?
Yes.
Yes, sir.
Okay, let's continue, please. A train takes 100 seconds to travel. please, I hope you have your calculator there because we'll be doing some calculations as we are doing. If you don't have your calculator,
Yes, sir.
please quickly get them. Okay, you have it. Good. Okay, good, good. Cadilo Barry, do you have yours?
Yes.
Okay. A train takes 100 seconds to travel 1,500 meters. What is the speed of the train? Very simple. 1,500 divided by 100, and that gives you 15 meters per second. Okay. I want to ask you this. If you have gotten speed, how do you calculate distance? What is the formula for distance? What would be the formula for distance? If you have gotten speed, what would be the formula for distance? Kadilo Barry. What would be the formula for distance? What would be the formula for distance here? Look at speed is d over t. What would be the formula for distance? Ayo?
So distance, that is speed times time.
Good. Distance, just cross multiply. Kadilo Barry, just cross multiply. D, this will be s over 1. That becomes d is equals to speed times time. Do you understand that?
Yes.
Speed times time. Okay. Let's go to the next one. I believe this is very easy. My goal today is to make sure that we understand distance time graph because it's very crucial. We need to know how to get distance time graph and the velocity time graph. That's my aim for today. Okay, now this is a distance time graph. You should know how to interpret this distance time graph. When something moves from here to here, you should be able to interpret what does it mean. Ayo, do you know what it means? When it moves from here to here, this bend means something. This straight line means something. This other bend means something. You should be able to interpret. Whenever you see a graph, at first sight, you should be able to interpret, oh, I know what is happening here. This car, from here, there's either a constant acceleration, there's either a constant acceleration, or there's a constant velocity, or there's a constant speed, or there's a deceleration. You should be able to understand what's happening. All right. Okay. Let's go to the next one. Now we're going to be calculating gradients. If you want to get the gradient of a graph, what do you do? This is how to make gradient. All you need to do is take your ruler for a distance time graph. If you want to calculate gradient, take your ruler, draw a straight line here, and then all you just need to do is, okay, let me get something here. Let me see what I can do with this. Okay, this is how you get gradient. When you've drawn your straight line, you trace it down. Sorry, please, it's not straight. Please, I'm sorry about that. You follow the line. This will be this one minus this one. Probably if this is 1, sorry, if this is A and this is B, then you drag this one down, you bring this one down, you bring this down, and you bring this down. That will be this will be A minus B over C minus D. Do you see that? This is how to calculate gradient. Because we'll be calculating gradient. Your ability to calculate gradient helps you know what you can do. Do you understand how to calculate gradient, right? I hope you get that. I hope you got that.
Yes, sir.
Okay. Quickly. Kadlo Barry, what about you? I hope you got that.
Please, can you explain again?
Sorry?
Please, can you explain again?
Okay. Let's look for something. Let's look for an example. let's look at this example. Okay, look at this example. What is the speed of an object from point A to point B? What's the speed of an object from point A to point B? Now, this is how to calculate it. I told you we're going to calculate gradient. All we need to do is from point A, there's a line there. Trace the line. Sorry, let me bring that stuff again. You trace the line, you draw, make it straight, 70. Take the other line. What's the other line here? This is what? 10. Do you see that? Now the next one is, bring this one down from this same point, bring it down, 3. And this same point, bring it down, 6. Sorry, that was very bad. 6. Now, how do you calculate gradient? Remember, when you are calculating gradient of any graph, when you calculate gradient of a distance time graph is also the same thing as speed. How do I know this is distance, this is time? What is the formula that relates distance and time? What formula relates distance to time?
Speed.
Huh? What formula, please? That's speed. Because speed is the same thing as distance over time, right? Isn't it? Okay, so now all you just need to do is 7 minus 10 divided by 6 minus 3. 70 minus 10, I said 7, 70 minus 10 divided by 6 minus 3. So what would be the answer? Do you understand that now? Do you understand that, Kadilobari?
Yes, sir.
Okay, we're going to do one by ourselves now. We're going to do this by ourselves. Okay. Ayo and Kadilobari, I need you to do this. What's the speed? What's the speed of this graph? From point 0, let's take this point as A. Let's take this point as A, and let's take this other one as B. So what's the answer? So what's the answer? Kadilobari? Zeno, if you are there, I need you to put your video now. If you can hear me, please use your video now. Ayo, have you gotten your answer?
So not yet.
Adilo Barry, what about you?
No.
Okay, Zeno, we just came in and we've been talking about, you just came in and we've been talking about distance time graph. We are calculating speed. Okay, I just taught them about slope, calculating gradients of a distance time graph. So all you need to do to calculate gradient of a distance time graph, all you need to do is, I used this example for them. This example that, okay, we want to calculate gradients of a distance time graph. They said, what's the speed of the object from A to B? Now, all you need to do is take this point A. This is a point A, and this is the point B. To calculate gradient, it becomes very easy. Please, I'm going to be ending this class very soon. To calculate gradient is going to be, you just drag this point here, 70, drag this other point here, this is 10, drag this one down, this is 3, drag from up, down, this is 6. That becomes 70 minus 10 divided by 6 minus 3. 70 minus 10 is 60. 6 minus 3 is 6. 60 over 3 becomes 20 meters per second. Do you understand that, Zeno?
Yes, sir.
Okay, now I'm giving you guys a classwork to do. My time is almost up. Okay, I'm giving you guys a classwork to do. This is it now. Calculate the distance, the gradient, the speed. If I use speed, if I use gradient, it's the same thing. Because in a distance time graph, we're talking about distance and time. That is speed. Speed is distance over time. So I need you guys to tell me from this point to this point, want to calculate what is the gradient. What is the gradient? Okay, so Kadilo Barry, what's the answer? You don't know yet. Ayo, what about you? Ayo? Ayo, you're muted. Ayo, what's the answer?
So I've never gotten it.
Okay, this is how to get it. You shouldn't waste time on it now. It's taking time already.
No.
This is how to go about it. Please look at this. Everybody look up. Look at this. Just drag this. This is the first one up. The other one is down, which is 0. That becomes 8 minus 0 divided by, drag this one down. What is this? 8. And what is this? 0 divided by 8 minus 0. 8 minus 0 is what?
So 8.
8, good. 8, the other 8 minus 0 is what?
8.
So what's the answer now? 8 divided by 8 is what?
1.
So what's the answer now? Tell me what's the answer? What's the full answer? Not just 1.
1 meters.
1 meter per second.
1 meters per second. That is it here. That's the speed. 1 meters per second. Awesome. So that's why I said it shouldn't take you time. It's very easy. It's choice, like some of you will say. Okay. Let's see. My time is almost up here. So we might have to, let's just see how we can go find acceleration. Now, acceleration is a measure of how the velocity changes. Acceleration is velocity over time. I told you about velocity, that velocity has to do with change in direction. Acceleration is velocity over time. Now, when brakes are applied, note this. When brakes are applied, you might need to write this down. Write this down, that a train accelerates in a straight line from rest. As it does, velocity increases. Now, when they say something starts from rest, what does it mean? that means initial velocity is 0. That's starting from rest. Initial velocity is 0. But once the train starts moving, when they say a train accelerates from rest, that means initial velocity is 0. And as the train keeps accelerating, what happens? It keeps moving. It keeps moving. Velocity keeps increasing. But immediately brakes are applied. Boom! What happens? There is a negative acceleration. Negative acceleration is also known as deceleration. I can see Zeno, you are not writing. Others are writing. Negative acceleration is also known as deceleration. Deceleration. Negative acceleration. Remember, what causes negative acceleration? When brakes are applied. When a car comes to rest immediately on the spot, deceleration comes in. Negative acceleration comes in. Okay. Now, this is acceleration. Acceleration is change in speed or velocity over time. And acceleration is measured in meters per second square. All right? I'm a bit fast because my time, I have just 4 minutes left. I have just 4 minutes left. Okay. Listen to this. A hungry cheetah spots a gazelle. A hungry cheetah spots a gazelle and decides to chase it. The cheetah accelerates. I need you guys to do this. The cheetah accelerates at 10 meters per second square. This 10 meters per second square, what is it? Is it acceleration or velocity or distance or time? This 10 meters per second square, what is it?
So I don't know.
Acceleration.
Acceleration. I told you acceleration is measured in 10 meters per second squared. So 10 meters per second square is acceleration. So they have given you the acceleration already, right? From rest until it reaches 20 meters per second. What is 20 meters per second? What is 20 meters per second?
Time.
Eh? It can't be time. That time is not measured in meters per second. What is 20 meters per second?
Distance.
What did I tell you is measured in meters per second?
Speed.
Speed. Velocity. Speed. Velocity. So 20 meters per second is velocity, right? So what do you think you're calculating here? What are you calculating here? They said, how long did this take? So what are we looking for?
So time.
We're looking for time, correct? That's cool. So now they've given you 10 meters per second, right? 10 meters per second is what? What is this? What's 10 meters per second again?
So the acceleration.
Acceleration. 20 meters per second is what?
Acceleration.
Velocity.
So,
How long did this take? Time. So what would be the formula? Remember, acceleration is equals to velocity over time. So what would be the formula for time? What would be the formula for time? If acceleration is velocity over time, what is the formula for time? What's the formula for time? Somebody talk to me.
Velocity of acceleration.
Thank you. Velocity over acceleration. Good. That becomes 20 meters per second divided by 10 meters per second squared. Right? 20 meters per second over 10 meters per second squared. That means time becomes velocity over acceleration. And that becomes 20 over 10,
And
which is
the have to
2 seconds. I hope you got that. I hope you got
Yes,
that.
sir.
Yes.
Okay, now the rule of this game is see, know your units. I told you from the first time we started, know your units. Acceleration is measured in meters per second squared. Velocity is measured in meters per second. Time is measured in seconds. Distance is measured in meters. If you know all these, you'll be able to solve any problem on this. So we'll be stopping here for now because my time is almost up. But I need you guys to attempt more questions on distance time graph. The next time we'll be meeting, maybe next week, Monday, we should be having acceleration. We should start with acceleration, velocity time graph. Do you understand that?
Yes, sir.
Okay, I believe you've gained something today. So invite your friends. Next week, we shall be having another amazing time, right? We'll be having an amazing time. I'll be sharing with you guys some videos.